In the next two videos, we will transfer our data from Python to MySQL. There are a few ways to do this. The one we've chosen is essentially about creating a query we will store as a string variable in Python, and then use as an argument of the execute method. And it is the execute method that will move our data to the predicted outputs table in Workbench. This may sound great, but we must go through some preliminary clarifications first. To be able to work with the dataset containing the outputs predicted by the model, we need to store its output in a Python variable. We asked you to do this as an exercise a few lectures ago, but if you skipped it for some reason, please make sure you have stored the predicted outputs obtained by the absenteeism model in a variable called dfNewObs, standing for data frame with new observations. Having done that, we can move on to creating the query to be run in MySQL. It will be an insert statement. Those of you who are in good command of SQL may consider the following brief explanation as a refresher on this type of statement. Everybody else, please don't worry. The SQL syntax is so intuitive that you will easily understand what we are doing as you follow along. So, here's how the final version of the query should look. The SQL syntax requires an indication that we want to insert data into a table from the relevant database. This means the query should start with insert into predicted outputs values. Then, we must add each record within parentheses. Also, we have to separate the records and their values with commas. Please pay attention to the fact that the query ends with a semicolon. Using this symbol is obligatory. It acts as a statement terminator, which implies the end of a query. These peculiarities validate our statement. In other words, once executed from the SQL tab in MySQL or through the execute method in Python, this query will insert the data from the dfNewObservations data frame into the predicted outputs table in MySQL. However, if we had to type the entire statement manually, it would take too much time, and we may unintentionally input many wrong values, thus sending erroneous information from Python to MySQL. To prevent this type of mistake, we will use iteration in Python in the following way. We will create a structure that will insert the row's information from dfNewObservations into a row in our database in MySQL. Then, we will create a loop that will repeat the same process for all rows of the data frame. And how can we do this? In general, one option is to produce a complete insert query ending with a semicolon. Then, we can run it as many times as there are rows with information in df. That is, when working in Python, this loop can be used to create many separate single-row insert statements. And then, these statements will be executed one by one. From a programmer's perspective, though, this is not optimal. Why? This operation may take a very long time to complete, and could even be the cause of interruptions in the company's data transferring process, thus hindering the normal flow of operations. The reason is that each time you execute an insert statement, the table in the database has to reorganize its structure. And the latter increases the total amount of time and resources required for the execution of the operation. In response to this, here's the alternative, which is considered best practice. We can use one multiple row insert. In fact, this is the type of insert statement we presented a couple of minutes ago in Workbench. It is preferable to stick to this approach because storing the whole query as a string in a single Python variable can significantly improve the insert speed. The reason is that the predicted outputs table will only have to reorganize its structure once, as opposed to multiple times, which would have been the case if we had decided to use multiple single-row inserts. Choosing one multiple-row insert instead means the time and resources required to process information from Python to MySQL will be reduced. And That's something we should always be aiming for. Although the distinction between the two approaches won't make a significant impact in our example due to the small amount of data we are transferring, we are advocates of using best practices and efficient coding all the way, so we will stick to the second approach. Here's a final note before we get back to coding. When the second approach is applied professionally and the dataset to be moved is much larger, a programmer may stumble upon a problem. The number of rows or values to be inserted in a MySQL table with a single query may be limited. This means that if, for example, a limit has been set to 20,000 rows and you are trying to insert 25,000, the program will display an error message and you won't be able to complete the insert all at once. You'll have to split the query into two parts, neither of which can contain more than 20,000 records. Nevertheless, merely transferring 40 new rows, we are far from such a problem here. So, please feel free to continue to our next video, where we'll analyze the loop that will help us finalize this operation. See you there!